Am I looking good? I don't know, but hi guys, welcome back to the Leetcode series. I know I have been disappeared for again few days because I'm shifting back to Mumbai, so yeah, that's why. But yeah, today's Leetcode question is Leetcode hard. It's 1510 Stone Game 4. Let's read the question and let's see what approach we are going to take. Alice and Bob take turns playing a game, with Alice starting first. Okay. Initially, there are n stones in a pile. On each player turn, that player makes a move consisting of removing any non-zero square number of stone in the pile. On each player's turn, the player make a move consisting of removing any non-zero square number of a pile of stone in the pile. Okay. Also, a player cannot make a move, then he or she loses. Given a positive integer and return true if and only if Alice wins the game, otherwise return false. Assuming both players play optimally. Okay. So we want to make Alice win, right? Okay, so what we are going to do, we are going to check if that number is perfect, then I equal n minus 1. Okay, let's try it. Uh, so basically we are going to find out the closest square number to n and remove it. If there is none, we remove. If there is none, we remove one. Okay. Bool check is bool Alice is equal to true. Bool Alice is equal to false initially. Let it be true. Wait. While my n is greater than 0, if is square and Alice is equal to true, then return true. False. Else, if not is if is square and and else equals false. Then return false. Else. It means it's not a perfect square. Else. For int not int temporary is equals to n. While n is greater than equals to 1. If is square and and initial step, then int val equals to m minus l, val is equal to n is equals to false. Square and l is equal to false. Int val is equals to m minus n, val equal to n, and l is equals to true. And for each case, give me n minus minus. Now next thing we have to write the square function. Bool is square, then how to write the square function. Hmm, power, yeah, power minus 2. Int val equals to power and minus 2. Double int val, let me see. If a number is a perfect square or not. We are going to see the GFG code. Bro, it's humid right here. I'm like literally sweating right now. It's currently 9:57 a.m. I woke up like 9 o'clock. No worries. If root is equal to square root of, okay. There is a function called root. Which I'm also right, but never mind. Root close root equal to then return true. Let's see. Now let's see how is my code working fine or not. I think so. It will, yeah, it will work for these test cases. Let's see how is my code is working for the rest of the test cases. For 3 it's giving me false, but look, the first time it's Alice, then it's Bob, then it's Alice, right? Yeah, that's right. Alice, Bob, Alice. So when it's go for here, it's, n is not a perfect square. It's when it's not a perfect square, I have to check that also. Else, nothing. It's never a perfect square. Okay. So for the, see, the thing is for a particular test case, like three is plus three is not a perfect square. Okay. Then we can do L is equal to true, is equal to false, else L is True, true. Maybe this is the case because uh, "ओ, तेरी बातें कुछ अलग सी." Okay, okay, okay. Let's see, let's see, let's see. I guess I have to do this thing at the last. Wait. Hmm. Because here I'm finding a perfect and right. Oh, still giving me answer wrong. Okay, let's see how. So it's not going to go for this case. I will make temp is good 3. Then I will make sure that it is true. Let me see out and for each part. Every time it's going to be one only. Oh, it's always cutting coming from one time. Okay. Oh well, no brother. It's n is equals to well, and here also it's n is equals to well. I think this might be the case. This might be the problem. Yep, this was the problem basically. So yeah, we sorted out the problem again. It's giving for it also. Like if you see 8, right? See it, then it will for ellipse it will become 4 getting cancelled out. So 8 minus 4 is equals to that's what I think it's doing. It's like 4 and 4 only for the 2 times. Yep, that's the case. So that's why it making the it's making the bob win. It's 2 times 4. Yes, buddy, I got it. But the question says any non-zero square number of the stone in the pile. Ah, so that's good, right? If you remove both the players play optimally, then so obviously Alice is going to lose in this case. Hmm. 2 10, 2 versus 4, and the 4 is the perfect score, so the Bob is going to win. Let's do one thing. Let me write here equal to it, 2 and 2. And let's see how many test cases it's failing for. 13 also it's getting failed. So there is something I'm missing in these test cases. I have to see the pattern. Plus 5 it is. The next will be 18. Next is 44 actually. Bro, it's 44, it's returning false. What the fuck? 47 is returned true. Now I'm not getting the pattern actually. Like where is the pattern? And it's 42 is true also. There's something I'm missing right now. And there is 99. So Alice took out 81 first, then Bob, then Alice. Okay, 81 got out first. Let me fix the 99 test case basically. When the 16 came out, to use this test case, buddy. I think my approach is kind of bit right, but I don't know like how for what it's getting filled right. So let me open a calculator. Basically, it's, if I do math right, so 6, 7, and 8, 98. So is he just want to make Alice win? It says now if and only Alice win then return true, and they're both playing optimally, right? So like if they both play optimally, then Alice always want to win, and Bob also wants to win. So it always like how many different ways, how many different ways, how many multiple square roots they can take to make a perfect sum. So basically, it's going to be like something like this. We are checking different ways with square root to make a perfect. There are different. We are checking different ways with square root to make a perfect and such that Alice wins most of the time. Look, if I take the case of 99, in this case, I take 99, okay. So how can I make 99? Closest square root is 81, but 7 is 49. 88 is 64. So if I take 88 is 64, right? If I list to 64 first. So 99 minus 64, how much is this? 35, right? 35, then 35. Then Bob will say 4 by 16, 525, 636. 636 is greater than 5, 525. 25, then left 10. If Alice turn, Alice will say, I will take 4, then it's leave with 3, 6. Then it's 4, then it's going to leave with 6. Alice, Bob, Alice. Then Bob is saying, okay, fucker, let me take 4. Then Alice is left with 2. Then Bob will say 1, and then Alice will say 1. So Alice, Bob, Alice, Bob, Alice, Bob. So in 99, Bob will win. Who is winning in 99? Bro, Alice is winning in 99. Okay, okay, okay. So Alice did what? So, what Alice is going to do, instead of using 4, if we go 2, then it will remain with 4. Then Bob is using 2. Bob can directly use now. So I will say 1. It's 5. When it's 5, Alice, Bob, Alice, Bob, Alice, Bob, Alice. No, Alice, Bob, Alice, Bob, Alice, Bob, Alice. And if it is 6, Alice, Bob, Alice, Bob. I don't think Bob would go with 1. So instead of, maybe I choose 16, right? And it's 19 here. Another 16. Alice, then it's 3 here. Alice, Bob, Alice. Then Bob, which is 1. Then Alice will Alice, Bob, Alice, Bob, Alice. Okay, okay, okay. But see, the Bob was also want to win, so why didn't he choose 25 then? That's the case. Okay, I guess we are missing something here. That thing, like currently Currently, we're missing something here. Currently, I'm missing something. To always be a pattern that when the last is 1 and Alice is true, now I'm doing it and try. Yeah, so I literally read this whole article, and this guy Debesh, bro, he make this question like way far easy. So this question is going to use a dynamic programming concept. Okay, so let me tell you like what is the core of this program is. So the core is of this program is every player want to win, right? So in order to win, what the player want to do, he want to detect such a number that his opponent is going to lose. And if a opponent or if a same player is going to lose, he will remove such a square root of a number such that he will going to win. So basically, if I'm in higher position and if I know currently I'm winning, right? So what I'm going to do, I'm going to remove a small square root or maybe biggest square root which led my opponent to lose. Otherwise, if I'm in a losing position, I'm going to remove a square root and I want to win a winning position. So for our case, we are going to go with the second step. Like we are currently assuming that we are losing game and we want to game win, right? So in order to win, what we are going to do, we are going to remove such a square root that we make ourselves into position that we are in a winning position. So that's what we are going to do. We are going to use a Tableau DP for this. The recursive DP is also there, but yeah, I think I'm more comfortable with the Tableau DP. So let me explain what this all 7 steps is. So it's easy for you guys also to understand. So we start with stone and we start with n stones. On each turn, a player can remove one square, two square, three square, four square, right? Like we are going to remove a perfect square. So stones, as long as chosen square is not greater than the number of remaining stone. Okay, the player who cannot make a move loses, basically. For example, if n is equals to 1, the first player can remove 1 square is equal to 1. So the first player wins. So that's simple. For n is equals to 2, the only possible move is to remove 1. So 2 minus 1 leads to 1. Now the opponent has 1 stone and can remove it. Therefore, the first player loses. This immediately tells us we need to keep track of whether each position is a winning or losing. So if I'm in a current position, I have to check whether this position is winning or losing. The most important DP idea, we define DP of I as true. If the player whose turn, it can be force a win when there are I stones remaining. If DP of I is true, it means that whenever whenever we are higher position, and it's true, it means that whatever we do we're always going to win. Like it it is kind of force a win where I are remaining stores. If I'm in a higher position, right? If there is two, I'm in the second position and the first position, and the first position is true, then I know, right, this is the place where I'm going to win, right? And the DPS of I is equal to 4. The current player is guaranteed to lose if both players play optimally. So if at any ith position it's false. It means like whatever I can do, whatever I can do, I'm going to lose at this position. If I have this ith stone remaining, like I have this four stone remaining, and it's false, then it means I'm going to lose, right? The current player is guaranteed to lose only if both players play optimally. This gives us two type of states. Winning state, current player can force a win. Losing state, current player cannot force a win. So winning state it means if I'm in any particular ith position, then by making some choices, I can win. I can make myself a win. While a losing state means that if I can do anything, I can't win. So the most important game theory rule. Suppose we are currently at position I. We can remove some square numbers. Like if I'm in first position, then I'm going to remove some square numbers, right? J plus j squares and move to I plus j squares. Why there is move to I plus j squares? So see, if I am in a j square position, I remove the j square and currently my I is the position from the start, right? That much is also remaining. So I will move on to the next thing. If we start from losing position, suppose d per 5 is equal to 0, that means that the player at I is going to lose. If another player can make a move that makes the game from I to some position I plus j square, then next position is winning for the player who made the move, right? Therefore, losing position make a valued square move, winning position. This is exactly what the code is doing. So why now? Now the question is why the dp of 0 is false. Let's start with dp Java that's so initially dp of 0 is equal to 4. That is correct. Why? Because zero stone currently there are no stones, right? So we don't have to remove anything. That's why dp of 0 is false. That is our base case. Now we are building up winning stages. So for the winning stages, we are going from 0 to n, and if the current dp5 position is false, that means we have to make some certain moves that will let the player to win. So we are going to iterate from j is equals to 1 till the perfect square roots and making them true. Now the next thing is dp is false, then dp is false, which means I is a losing position. So yeah, I got like what they are doing. So let's try and code it down. It's like this is all about how the code will is going to work. So it's nothing like nothing important here. So yeah, no worries. So vector bool dp of size n. Okay. Now we are going to start with the 0 till then and I plus plus. If dp of I equal to false, then I have to like start making the moves, right, till the position where I can reach and make a value in. So dp of I plus j cross j is equals to true. Return dp of n. Assume that is the only case. Now after this is dp of n. Now to return true, else we have to return false. So if I is a losing position, every valid square move from I creates a winning position. If deeper phase falls, then once n become reachable from a losing position, the first player can force a win. So here is basically going to be Cali's win. So from any position, if Alice is, oh, it's is equals to true, it's not equals to true. So I like get 70% of the question, like it's a DP question basically. I get 70% of the question, but still I'm a bit confused. So I will try one more time this question by my own. But yeah, that is a today list code question. I took help from this editorial, this solution. It's very good by Devesh P. And that's all for today. We solve a lead code hard. So, yeah, bye bye.